We all know that buildings are ecosystems which consume energy and produce waste. This section focuses on buildings and cities, and we'll go through some solutions that make buildings and cities contribute to the drawdown. And there are already some reports saying that every single building in the world would have to be net zero by 2050 if we are to meet the 2°C global warming target with 66% probability. We'll leave that there and come back to further details later on. Let's start looking at this section with net zero buildings. Ranking and results by 2050 is at number 79. Cost and savings modeled in renewable energy, LED lighting, heat pumps, insulation, etc. So they are included elsewhere. I just wanted to throw in some details about broadly the urban versus rural growth over time. So this is just showing number of people living in urban and rural areas worldwide from 1960 to 2017. Not surprising, lots of people used to live in rural areas, but over time the urban population has picked up, and there is a relation between GDP and urbanization, people living in cities and so on, and there are statistics that show that city centers, cities in general, can be hubs of innovation, number of patents, metropolitan population tends to correspond to number of patents and so on and so forth. Leaving that aside, looking at 2017 as share of population living in urban areas, you can see that the rich countries have significant number of people living in what we would call urban areas, not necessarily cities, because that also includes urbanized neighborhoods. Cities have certain definitions which we are not going to get into specifically here, but I think you know some of the biggest cities in the world, starting with New York and San Francisco, London, Mumbai, Delhi, Beijing, and so on and so forth. So this just gives you a sense that urban populations are spread all over the world, and obviously increasing as well. And cities and urban populations always also bring up the idea of slums, very crowded shanties where people live, and this is the share of urban population living in slums in 2014, and surprisingly India here shows up as quite small. Indian cities are some of the largest in terms of populations, if you think about Kolkata, Delhi, Mumbai, Bangalore, Chennai, and so on. But African countries here show up as having lots of slums, and so do poor countries here in the Western Hemisphere like Haiti, Dominican Republic, and so on and so forth. Number of people living in urban slum households in India, this is going from 1990 to 2014. So urban population not living in slum households has increased, and urban population living in slum household has decreased over this time. So basically corresponds to a growing middle class, economic development, per capita GDP increase, and people building more pakka houses or non temporary houses, if you will. Share of the population living in urban areas by 2050 is obviously expected to increase in regions where it's low right now. So you can see that in a country like India going up to about 60%, and people are getting closer and closer to the coast as well. And urban and rural populations projected to 2050 by world standard, or worldwide, going from 1500. You can see that urban population increased in the 20th century and is expected to increase tremendously in the 21st century, and rural area may peak around somewhere in the 2030 or so and then start to decrease again. These are projections which also depend on various assumptions, including overall population increase itself, which have lots of uncertainties. But looking more specifically back to now at net zero buildings, this is a good example of a building in Colorado, the Rocky Mountain Institute Innovation Center. It's a net zero building on the north shore of Roaring Fork River in Basalt, Colorado. The two-story 15,600 square foot building was constructed using integrated project delivery software and model, a replicable process that can be employed by commercial projects around the country of similar scale. So they have codified the technology, and it can be used elsewhere, which is always great. Although located in one of the coldest climate zones in the United States, the insulated building envelope was built with R50 walls, that's an insulation rating, R67 roof, another rating of the building insulation, heat and cold retention and loss. It has an 83 kilowatt solar photovoltaic system on the roof that provides more energy than the building is designed to use. The building was designed to use less water than the rain and snow that fall upon the site, less than what falls there. Although grey water use is not allowed as yet in Colorado, a grey water system was installed in anticipation of changes in the state regulations. So they expect that Colorado will adopt regulations on the use of grey water, which is basically recycled water which can be used for various purposes like flushing the toilets and gardening and other purposes. To save heating and air conditioning energy, the center focused on heating and cooling people, not the space. Okay, so you have 15,000 square foot space, but the number of people is what will be the focus for heating and cooling. They addressed the 6 factors that affect human comfort, which are air temperature, wind speed, humidity, clothing level, activity level, and the temperature of surrounding surfaces. By zeroing in on these factors, the center has a broader range of comfortable air temperatures from 67 to 82 degrees Fahrenheit compared to the conventional commercial building ranging from 70 to 76 degrees. This cut energy use by 50%, eliminated the air conditioning system completely, and requires a small heating system only on the coldest days, and it has internally space arranged stairways and light, external light instead of artificial light, and so on, so that people feel encouraged to walk, productivity goes up, comfort goes up, and interactions go up, and so on. This is at least at the time was the largest net zero building in the world. I think United Therapeutics in Silver Spring, Maryland, just outside DC, and this is a cute energy wheel which uses real-time data to illustrate the energy use in the building, which is kind of cute. Lets people watch it and feel how much energy they're using. So this is typical of these stair-friendly, walk-up-down friendly building design, where people are encouraged to walk rather than take elevators, unless of course you are handicapped and so on. There are no numbers at the top of this page because net zero buildings are a mosaic of separate solutions. So they have focus on energy, water, recycling waste, and recycling water, and so on and so forth. They draw on smart windows, green roofs, efficient heating, cooling, water systems, better insulation, distributed energy and storage, and advanced automation, so that lights come on and off, heating cooling systems come on and off based on people, and not stay on all the time and require manual on and off operations. All are treated individually in our analysis. If net zero buildings are calculated as a single solution, assuming 9.7% of the new buildings will be net zero by 2050, the integrated opportunity is 7.1 gigatons of carbon dioxide. Of course, there are co-benefits in terms of productivity, labor lost, and so on and so forth, health, etc. As I said before, this number of 9.7% new buildings being net zero may be too low for some of the global warming targets, so that has to be considered separately as well. So let's leave this here and then move on to the next component of buildings and cities and their contribution to drawdown.